Good morning, students. So today we are going to discuss the last two topic of chapter 1, real numbers. The first one is proving a given number as irrational, and the second, decimal expansion of rational numbers. So, in the first topic, proving a given number as irrational, there are two types of number which we will face. The first one is simple, root 3, root 5, root 7, root 11, etc. And the second one is a combination of rational and irrational numbers like 2 plus 3 root 5, 3 minus 2 root 7, etc. Both we are going to prove using a method called contradiction method. Contradiction method means first we will assume this number as rational and then we will prove our assumption incorrect, and this method is called contradiction method. So let's start the first type of numbers, that is root 3, root 5, root 7, root 11, any of the numbers. So let's take root 5. Now, in order to prove this root 5 as irrational, we will assume that this root 5 is a rational number, and we all know that any rational number can be expressed in a form of a by b, where a and b are integers, b not equal to 0, and they are no common factor other than 1, means they are. So let root 5 is equal to a upon b, where a and b are integers and b not equal to 0. There is one more condition for a and b, that a and b are also co-prime, means no common factor other than 1. So this we are assuming root 5 is equal to a upon b. So let's root 5 is equal to a upon b is our equation 1. So we are going to square the both sides of this equation. So squaring both sides of equation 1. So this root 5 is square and a upon b is square, or 5 is equal to a square upon b square, or 5b square is equal to a square. Here both 5 and b square are the factors of a square. So if here 5 is factor of a square Therefore, there is one theorem. 5 will also be the factor of A. If 5 is the factor of A, then we can write A is equal to 5C, where C is any integer. Now putting this value of A in equation B, putting A is equal to 5C in equation 2, then 5B square is equal to 5C whole square, or 5B square is equal to 25C square, or B square is equal to 5C square. Again, here 5 is factor of B square, therefore 5 will also be the factor of B. Now here we can see 5 will be factor of A, 5 will be factor of B, but we assumed this A and B are co-prime, means no common factor other than 1. Now, why this contradiction arising? This contradiction arising, now we are going to rub the first. Now this contradiction arising because of our incorrect assumption. This contradiction arising because of our incorrect assumption. That is, root 5 is rational. Hence, root 5 is irrational number. This is the first type of number, that is root 3, root 5, root 7, root 9, etc. The second type of the number, that is B, is a combination, I told you, 3 plus 2 root 5. Now let's see how we are going to prove this 3 plus 2 root 5 an irrational number. Again, for this we assume let 3 plus 2 root 5 is equal to A by B, where A and B are integers and B not equal to 0. Also, A and B are co-prime, means no common factor other than 1. Now, what we are going to do now? We can transfer this 3 that side, so it will become 2 root 5 is equal to A upon B minus 3, or 2 root 5 is equal to A minus 3B upon B by taking B as LCM, or root 5 is equal to A minus 3B upon 2B. As we all studied in our class 7 class, that the sum of two integers is integers, the difference of two integers is integers. So as for irrational numbers, the difference of two irrational numbers is rational, and the division of two rational numbers is rational. Means the RHS part of above equation is rational, and we already know that root 5 is irrational. Therefore LHS not equal to RHS. Again this contradiction arises because of our incorrect assumption that 3 plus 2 root 5 is a rational number. This contradiction arises because of our incorrect assumption. Hence 3 plus 2 root 5 is irrational. I hope both the two proofs will help you to solve the next exercise of your NCERT, exercise 1.3. The next topic and the last topic of this chapter, real number, is the decimal expansion of rational numbers. Now, in our previous class, class 9, we studied that the decimal expansion of rational numbers are of two types. The first one is a repeating and non-terminating rational numbers, and the second one is terminating type rational numbers. So again, we are going to revise these two topics as our last topic for the current chapter. So rational numbers on the basis of their decimal expansion classified in two parts. The first one is terminating decimal expansion, and the second one is non-terminating repeating decimal expansion. So rational numbers. The first one, terminating decimal. the second one is non-terminating but repeating, also called recurring decimals. In terminating decimal expansion, the denominator of the given rational number is a factor of A, either 2 to the power m or 5 to the power n or both 2 to the power m into 5 to the power n. Means in the terminating decimal, the denominator's factors are strictly 2 or 5 or both. In non-terminating decimal expansion of the rational numbers, the denominators is other than 2 or 5. It can be 2 but some other number, 5 and some other number, or both 2 and 5 and some other number. The denominator is other than 2 or 5, that is combination of two and other number combination of 5 and other number, combination of 2 and 5 both and other number. It's a very easy concept. This we already studied in our previous class. So hope you understand what all I taught you today, and this will help you. These two things will help you to solve the last exercise, that is exercise 1.4 of your NCERT chapter 1, real numbers. And thank you for today.